Hello guys, welcome back. So I wanted to talk about the geometry preparation, and again, each character or each object you have presents its own challenges. And what I've been doing is, for example, in this case, I would create a for each loop. Let me unpack this. So it's a real geo, and then I'm going to create a connectivity node. And then here, let's loop over each shape by the class. It's a primitive attribute. Okay, so in each of these I would create a TID-Rahalize node and then set it to convex hull and polygon. And it will create something that encompasses everything. And you can see we've gone from let's see, from this to this. We've gone from this to this, and this is going to be much easier to generate a volume from because it doesn't have any hulls. And when you have hulls in the mesh, it's going to be generally very tricky to fix them, and this is one way. Now, of course, we're losing a lot of details here, but most of the cases you don't care about that. Now, the other information that is very important for this system to work is the velocity, and if you start creating new geometry to represent your own geometry, your old geometry, you're gonna have to pass in that velocity vector somehow. And so in this case, V with TID-Rahalize gets passed correctly, so we're good. We're good on that. Let's move on to a different frame. Yeah, so we have the velocity vector, and then that gets copied. We can fill interior and sample our point.v poly file. Now, in the Robot case, to be honest, I was very lucky. I didn't have to do that. I just took the original pardon me. I took the original geometry and ran it through the VDB node, and I was able to get something very that worked out of the box. This is not the case in a lot of other meshes. You can see already that this mesh will work. So what you need to do in some cases is request that from the modeling department if you don't have that, and or find ways to create it in Houdini. The fracturing method that I mentioned does not work with a deforming mesh. It presents other challenges because you have to keep that new mesh deforming with the original mesh. In this case, the TID-Rahalize is happening every frame. You can still fracture every frame and generate a new mesh as well, but I think the TID-Rahalize will be a better option for that. Now, in some cases, the TID-Rahalize node does not give you the result that you want, so you may have to go and fracture each piece by itself. So you fracture each geometry into a lot of smaller pieces and then run the TID-Rahalize every frame. There is ways to deform the generated TID-Rahalize mesh with your character if you have a static mesh, sorry, not a static mesh, but something that doesn't have vertex deformation, like a robot, for example, where it has everything metallic, or a car or something like that. But if you have a character with a skin or a lot of vertex deformation, then you're going to have to find other ways. Now, this is the result that I have used in the sim. I'll show you that. So this is the actual robot. It's yeah, it's not high res, and then it's moving from frame. Let me see. And it's animated. And you can see it's quite heavy to load in the cache and display it, but in the sim, this second it takes to read in the cache, it's not a big of an issue. And this is not going to impact the sim time at all, which is another huge advantage. It's going to impact the sim time in a way that it's going to change it, and most likely more voxels are going to become active, but that's the behavior of the sim. Now I have the other sim going on the background here at a higher resolution with the grid resolution set to 2, which will help the collision a lot. Cool, so I'll let that run and then we'll continue in the next video. Thank you guys for watching and see you in a bit.